Welcome to this session. It's session 5AK. Steve Warren will be talking about zOS container extensions, part 1, an introduction to running containers inside zOS. Throughout Steve's presentation, if you have any questions, please raise them in the chat box and Steve will answer as soon as possible. So without further ado, Steve, the floor is yours.
Thank you so much, and welcome everyone to our talk here about zOS or zOS container extensions. This is an introduction, and it's part 1 of 3 parts. And we'll have some more details later on about the parts 2 and part 3. Let me just tell you a little bit about myself. I work across the pond in New York State, in IBM Poughkeepsie, as a technology architect. And we help clients just embrace some of the latest technologies on zOS. And so today we're really going to have an introduction to a technology that's been out there for a couple of years, and that is zOS container extensions. And so with that, we're just going to continue right on. Again, this session is for you. So if you have questions, please post them and I will try to answer them as I see them. And if one of the room monitors here, if they want to notify me every so often if I didn't answer a question, please feel free to do so. So my email is here. If there are questions that you maybe didn't want to raise during this hour, or that things that process in your mind after a little while and you want to ask me, feel free to reach out to me. We've had already some of my earlier sessions in the week. We've had people send emails and it's been a great interaction. But I always love the GSE, and it's a great conference, and I hope you guys are getting a lot of great education from all the great sessions that the GSE is offering in this virtual conference. All right, so let's talk a little bit about what we're going to talk about. So the first thing is we're going to talk about what is zOS container extensions, what does it enable me to do. We'll talk a little bit about some of the technical underpinnings of how it actually works a little bit. And then we'll briefly talk about how do I get started with it and how do I manage and monitor it. Of course, these are all very at a high level. Some of the sessions that we'll talk in part 2 and part 3, we'll get a little more details of some of the particulars with some of these topics. So again, let's just dive right in. So let's just talk a little bit about the zOS software ecosystem and what ZCX brings to the table. So for many, many years, zOS has been about running online transactions and using traditional middleware products to have high availability and high throughput transactions on the system. And, zOS being the system of record for a lot of our enterprises, this is a very important thing. So for many, many years, we've had COBOL PL1 assembler applications. We have batch programs that are deployed in these middleware infrastructures to be able to run a lot of our workloads. In many years ago, 25 years ago or more, we introduced something called Unix System Services. Of course, it was Open Edition, OMVS, whatever the history with that. We had the ability to run Unix applications because zOS was a certified Unix operating system and still is to this day. So now with this Unix personality, we were able to take an application that was maybe running on some other Unix box, recompile it on zOS, and it would magically run in this thing called Unix System Services or zOS Unix. Okay, this opened up the world to lots of new applications. We could run C++ applications. Those were the typical applications that were being ported over, C and C++. And with, of course, C and C++ coming over, we were able to eventually deploy Java on top of this Unix System Services environment. And so, of course, we have a great JVM that runs on zOS. And of course, that also gave rise to being able to use things like WebSphere to be able to do web serving of applications. And then we on top of this Unix system services environment, we also have the concept of zOSMF, a great way of managing zOS. We have Spark and other analytics packages that now we can port over and run on zOS directly for native analytics on the system. And we have enablement tools such as Zoe that all help this to be enabled. Again, based on this new part of the ecosystem, the Unix system services. So what we're talking about here is the next evolution in the ecosystem of zOS, and that is zOS container extensions, the ability to take unmodified Linux on Z binaries and to be able to deploy them and run them directly on zOS as long as they're packaged as Docker containers. As Docker images, excuse me. So this is what we're talking about evolution. We had traditional workloads, we had Unix system services, and now we have these whole other set of applications that now can run directly on zOS, zOS container extensions. Okay, so what is zOS container extensions, or ZCX as we call it for short, and I'll probably use that for the most part. And pardon my American English, always saying Z instead of Z. So I probably will not get it right and say Z for you guys. So just bear with me as I say Z. This function was in zOS 2.4. It first came out, so that's about 2 years ago. Of course, it's on 2.5 with a lot more functionality and features and enhancements that have been delivered over the past 2 years. Again, this allows you to deploy Linux on Z software components as Docker containers on a zOS system. So that means that any application that runs on Linux on Z should transparently be able to run on ZCX without any modifications. That being said, if you have applications that run at x86 or other platforms, we provide an infrastructure for you to actually rebuild those applications to run on Z. Why on earth would I want to do that? Well, it really, the linchpin of the value proposition with ZCX is when we talk about Linux applications that are in direct support of zOS workloads. What do we mean by that? It means if you have a Linux application that is interacting with a zOS application in any way, or a Linux application trying to get access to zOS system of record information, etc., those are the workloads that where running the Linux application on ZCX makes a lot of sense. Okay, we co-locate those applications together and we get some incredible benefits by doing so. The first benefit that's listed here is without requiring a separately provisioned Linux server. You know the drill. When you deploy a Linux application in the world out there, normally when you deploy the application, you also provision a new Linux server to run that application. With ZCX, that's not necessary. You do not need to provision a separate Linux server. This can provide significant benefits. If I have a Linux application that's supporting something on zOS, or I have something that allows me to visualize something on zOS, but it runs on Linux, I had to go maybe to another group in my organization to get them to stand up a Linux server for me so that I can run this application. No longer, I have, as a zOS guy, I have the ability to actually run that directly on zOS, right? Okay. Probably the most significant benefit of running this, again, with that co-location, is to significantly improve network transaction rates and reduce latency. By co-locating your Linux application and your zOS application on the same server, I'm able to use some pretty amazing technology. We're going to see in a couple of slides when we talk about ZCX network integration with zOS, we're going to talk about the specifics of that technology. Suffice it to say right now that when you're communicating between zOS and a ZCX application, you are doing a memory move in the same address space, between address spaces. So there is no need to actually go over the network card or to do anything through the lower layers of the TCP/IP stack when communicating between these two applications. What does that mean? It means that I can, in many cases, meet SLAs of my zOS application very easily and still invoke a Linux application as part of within that SLA framework. And so we're going to talk more about that in just a few moments. But a big factor is you're going to have significant rates from some clients that we've talked to, and we'll get into this in more detail. They've seen when they've done performance comparisons that ZCX is through the roof in terms of the number of transactions that they can run because it is co-located and we don't have to deal with all that network latency that goes on. Another benefit is, again, maintaining the overall solution, the overall solution operational control within zOS. You know how it goes. When I have a hybrid application that has a Linux component, a zOS component, and I have them on different servers, I have different admins, I have to deal with a strategy for disaster recovery, for example. What about the priorities of that workload? Is it going to match up with what's required by my zOS application, for example? If I have it running on zOS, that control is in my grasp to be able to affect how that thing runs, how our recovery strategy for it, etc. I also can leverage the zOS qualities of service. And what we mean by that is you're going to see that ZCX leverages existing zOS technology as the underpinnings of how it operates. What does that mean for you? It means that your Linux application, which doesn't even know it's running on zOS, let alone leveraging these qualities of service, gets the zOS state-of-the-art qualities of service for free. And so you're going to see that that is a key benefit as well. So these are some of the main benefits of running ZCX. We're going to dive into some of these in just a little bit. Okay. Now, what is actually required when you're going to run ZCX? Well, the biggest thing is besides zOS 2.4, you're going to need a particular level of hardware, and that is either a Z14 GA2 or a Z15, any model and any GA level, right? So you're going to need to have those levels of hardware, and you have to activate the ZCX availability. And so the way that we basically make ZCX available on these different Z14s or Z15s is through a couple different mechanisms, and you have a choice. The first one is you can install the hardware feature code 0104, which is called the Container Hosting Foundation hardware feature code. If you already have that feature code, it's a no-brainer. You already have ZCX available on your machine. You may want to consider purchasing that. That's a one-time charge type of hardware feature code. Once you enable it on the KEK, 1 to n any number of LPARs within that KEK can leverage ZCX. So that's one choice. The second choice is a more recent addition to the enablement of ZCX on a KEK, and that is to consider the monthly licensing charge model of installing the IBM Container Hosting Foundation for zOS components. And so if you install that component on zOS, that will also enable any LPAR on the entire KEK to be able to leverage ZCX, okay? Now, if you are not sure if ZCX is right for you, you want to do a proof of concept or a proof of technology, or you want to do some kind of a trial, ZCX does provide a try and buy capability that lets you optionally kick the tires for 90 days with no additional charges whatsoever. So that is a strict 90-day limit from the first time you stand up a ZCX. You'll have a 90-day clock will start. And this is enabled very simply. We'll talk a little bit more about that, how you can enable that in just a few moments. So again, this is the value proposition that ZCX provides, and then this is how you enable it. zOS 2.4 or higher, and a Z14GA2 or higher. Okay, and then the last thing is here is the design thinking hill statement. So in IBM's and a lot of other software companies, when we're trying to develop a piece of software, we try to have a statement which sort of summarizes what the purpose of a particular function or particular component in this example is trying to accomplish. And so I'll just read this. A solution architect can create a solution to be deployed on zOS based on components available as Docker containers in the Linux on Z ecosystem, transparently exploiting zOS qualities of service without requiring zOS development skills. This is really the goal of ZCX, and everything that you see related to ZCX really can be summarized by that single statement. Okay, let's move on. So before, I kept mentioning that okay, you can take Linux on Z binaries packaged as Docker containers. So for a lot of the distributed world, they already know what Docker is. It's the open source standard for packaging software, right? And particularly in a containerized framework, right? But for those of us on the zOS side, we might not really have an understanding. So just a very high level view, again, it is a packaging standard for software, and basically it's a very different model than what you may think of a traditional installing of software on, for example, zOS. Basically, everything inside of that image that we have, which then becomes a container when we run it, but everything inside a Docker image is there that is necessary in order to run the applications that you want to run. So there is not the concept of ++ holds in Docker. There's not the idea of prereqs and coreqs and all the other things that we're dealing with SMPE, for example. Everything is packaged into the Docker image that is necessary to run. So that could be an OS, it could be programming languages, it could be other supporting software that we need to run. It's all inside that. And what that does for us is it makes installation very easy. And if it runs in one place on Linux on Z, it's going to run on another place in Linux on Z pretty much always, because we have everything inside there that we need. We're not depending on outside things in order to run this software. And again, it's very common in the application world on Linux and cloud. So out of the box, when you install ZCX, there are a whole bunch of packages that are available. And we're going to talk a little bit more about IBM providing you some additional vetted packages in just a moment. But for example, if you go out to Docker Hub right now and you search on S390X, which is the architecture of applications, the architecture designation of applications that run on IBM Z. Those applications which run today on Linux on Z, they run also on ZCX. And simply by clicking on this link that's in this the PDF handout, you can go and start to see all the applications that right out of the box when you install ZCX that can run on zOS in ZCX. So again, we're trying to reduce the complexity and we gain a large number of packages out of the box by supporting this Docker framework. Okay. So let's talk a little bit more about what's under the covers here, and then we'll just gradually peel a layer of the onion off each time. So ZCX is referred to as a turnkey virtual Docker server software appliance. I know that's a mouthful, but it really summarizes well what we're trying to accomplish with ZCX. So the first thing we need to understand is that it's a turnkey solution. IBM has prepackaged a number of items inside of a ZCX server that enable you to be able to get up and running right away. You don't have to procure your own Linux kernel or your own Docker engine or some of the other tooling that's provided inside of ZCX. Instead, you have access to be able to almost immediately deploy your containers. So not only is the software provided by IBM, but it's maintained by IBM too. And on a regular cadence, IBM provides updates to this appliance in the way of service. And there's easy ways of using workflows in zOSMF that I can apply that maintenance to my zOSs. Okay. So the next thing we needed to tell about, again, is just what I alluded to, provision using zOSMF workflows. In order to stand up a ZCX, there's a lot of questions and there's a lot of setup work that needs to take place in order to deploy this application. So what better mechanism than, rather than running a gazillion jobs or shell scripts or a bunch of other utilities to stand up a ZCX, instead, zOSMF workflow that's provided by ZCX will actually walk you through all the information it needs and then automatically runs a whole set of jobs and shell scripts and other functionality to stand up the ZCX instance that you're trying to do. Okay. And again, the idea is that once this is stood up, I'm going to have standard Docker interfaces that I can connect to for this particular ZCX application. And once I stand this up, the Docker admin can be a Docker admin on a distributed platform or on some kind of a Linux that's used to using Linux on Z and Docker. They can just have a zero learning curve. They can SSH into the ZCX appliance, and they can log on and they can use all the Docker commands that they're familiar with using, right? A couple of things on this chart that we should point out. Again, it uses the high-speed cross-memory virtual network function that we'll talk about in just a few moments. And that by doing that high-speed cross-memory virtual network, again, the latency is almost at the minimal level possible. An important point to make here is that because this is a prepackaged appliance, the Docker admin can do Docker commands and has some amount of traditional zOS Unix shell commands that are at its disposal, but it does not have direct access to the underlying Linux kernel because it's an appliance and it's maintained by IBM. We can't have you mucking around with some of the internals of the Linux operating system. And so there are some controls to limit the access. And again, this is managed as a zOS process. So this ZCX virtual Docker server address space is in fact just another address space. And you can manage it using standard zOS operational procedures. The last point I want to make here before we get into a little more detail is that ZCX workloads are zip eligible. And in fact, almost close to 100%. We have measurements that range from 95 to 98 and even 99% of the workload can be offloaded to zip engines. That results in not affecting your MLC costs that you may incur otherwise if it was deployed on a general purpose processor. Okay. So that's some of the real basics of what we're talking about. We'll, in just a moment, after we deal with a couple other slides here, we'll go back to unpeeling the onion a little bit more in regards to ZCX. I'll just pause right now. Are there any questions that folks have? You can please post them on the chat. I don't see any right now. I will wait a second and then I will move on. Okay. So we talked about that ZCX allows applications to exploit zOS qualities of service. So what do we mean by that? Well, let's just look at a couple areas where zOS has some great qualities of service. Let's look at the second column first and talk about zOS storage resilience. We haven't talked about it yet, but I will tell you that the Linux disks that the ZCX appliance utilizes are actually vSAM linear datasets. So the application running on ZCX, they don't know that they're using vSAM. In fact, they don't even know they're running on zOS. The application developer is not writing to a zOS interface. They're writing to a standard application that you would write on Linux. But the disks that we actually are writing to, both the engine of ZCX and as well as all the user disks and where the application's running. It's all running using vSAM linear data sets as its storage location. And so what happens when you're using vSAM linear data sets? Well, I have all the features of vSAM. So I have hyperswap and encryption, et cetera. We'll talk more about that in just a few moments. But as you can see, you're leveraging the storage. You have storage resilience that is state of the art, that you have available. All the different technologies that you have available for vSAM, you have available for ZCX. Let's talk about disaster recovery. We alluded to this before. Because I have the application hosted on zOS, there's no need to coordinate with non-zOS admins when I'm planning a maintenance window, when I'm moving workloads, when I have a disaster recovery solution I need to work about. I can use standard operational procedures for my disaster recovery and planned outages, whether it be GDPS or other technologies that I use for zOS today. When we go over to this third column and talk about network virtualization, well, we leverage technologies that are found in ComServer, and that is dynamic virtual IP addresses. So each ZCX is going to have their own dynamic virtual IP address, but what's good about virtual IP addresses is that I have additional resiliency. When I need to move an IP address over to another system, and when I need to move my ZCX over to another system, so that I can apply maintenance to one of our systems and still have the same amount of ZCX servers running, I can do that fairly non-disruptively using DVIPA technology, where the dynamic virtual IP address moves to that other system in a very dynamic fashion. I also am leveraging existing technology for that high-speed communications, across memory communications, using something called same host. We'll talk about that a little more. And I'm still using Workload Manager, so I can give priorities to my work in ZCX using WLM. I still have Capacity Provisioning Manager support if I want to dynamically add or remove capacity. And I also have SMF chargeback because I'm dealing with a ZCX address space. I have the standard SMF controls, type 30s, et cetera, for dealing with my ZCX workload. Okay, very cool. All right, let's continue on. All right, so when we're talking about use cases, let's talk about some of the reasons why you might want to deploy an application in ZCX. And we're going to be talking about this for an entire session in session number 3 later on. I believe that's next Tuesday at the GSE. So stay tuned for that one. But this is just a high level overview of some of the use cases and why you might want to use ZCX. So again, to exploit the latest microservices, if you have a zOS application today that is leveraging a microservice or would like to leverage a microservice, but you want to be able to have control of that microservice and you want to have optimal performance when invoking that microservice, and that microservice only resides on Linux, guess what? You're in luck. You have a solution, ZCX. What happens if I want to deploy a non-SQL database like MongoDB, for example? I can deploy that directly on zOS. Does MongoDB run natively on zOS? Well, it runs in ZCX. So I can have that co-location of my non-SQL database in conjunction with my other zOS workloads. I also, again, as we mentioned before, I have the ability now to have the system of engagement and the system of record to actually be co-located. So when I'm invoking a particular application and it before was on a Linux server and then it has to then go over to zOS to actually get the data, and I have multiple hops, I can reduce the number of network hops as a result of that, right? Also, analytic frameworks. So we've done a good job on zOS of porting several analytic frameworks to the zOS platform natively. However, there are lots of other analytics frameworks that have just not been ported, or they'd be quite difficult to port. I can leverage those analytic frameworks that are not available on zOS and run them co-located on zOS. Think of TensorFlow, for example, as a major analytic framework that now suddenly runs directly on zOS. Ooh, that's cool. I can do scoring and inferencing directly on zOS. What about messaging frameworks? I can now run the very popular messaging streaming technology Kafka natively directly on zOS, side by side my zOS application. Again, avoiding network hops and to provide that. MQ client concentrator as well for to provide again some better availability and other functionality. And then things like App Connect Enterprise. I can now transform my applications in terms of the data that I need to transform input data into another form in order to invoke another application. I can do that very simply. I can leverage all the features of App Connect Enterprise. Web server proxies. And what about emerging programming languages environments? We know that zOS supports a lot of new programming languages natively, but there are emerging programming languages which, it takes a while sometimes for zOS to support natively. So in the case of this, I can now leverage those programming languages directly, and applications that may be in a particular language, I can now run still on zOS without having to port that into another language. System management components. So I think of Service Management Unite as a really good example of this. Here we have a system management component that supports visualizing zOS through its many dashboards. But in order actually to run that piece of software, you have to actually run it on a Linux-based server. Well, some folks have said, well, that's a real pain in the butt because my Linux group, I have to now go out and make a request to them to deploy the server. I don't have control of that server, and yet it's all about managing my stuff. So wouldn't it be great if I don't need to deploy a separate Linux server and I can actually deploy it directly on zOS for system management? And then we also have a whole set of open source application development utilities. So imagine that now I can have my zOS software in terms of the source code management of that software, the CI/CD pipeline, all can now run directly on zOS. We have some folks, again, it's the same thing. They have to, they're being told they need to embrace these modern technologies, and rightfully we should move forward with open source development utilities. At the same time, it's nice if it can be co-located on the same system of which I own and which I maintain. And so again, all of these tools are available in ZCX. Okay. With that, let's talk a little bit more, peel the layer of the onion off, and let's look at storage integration. So as we mentioned before, we have this concept of Linux disks that run that we need to be able to write to, because again, whenever your Linux application is reading and writing, it's reading and writing to Linux disk. It doesn't know that it's on zOS. And so how are we going to accomplish that in a very high-performing way, in a way that causes us to not modify the Linux kernel? Because I know when we talked about ZCX, there's some clients that, oh boy, here we go. We have an existing Linux kernel, and you guys have modified it, and to be able to accomplish being able to leverage zOS technologies underneath the covers. The answer is a resounding no. That's not what happened. Instead, the ZCX developers leveraged a published interface and well-used interface that folks use when interacting with storage and networking, which are called VirtIO devices. And VirtIO devices, you can think of them like almost like device drivers. And basically, whenever you write data to the storage device, it's going to go through the VirtIO storage and the ZCX virtualization layer, which is part of actually zOS, and is eventually going to go into vSAM. So basically, all those Linux calls are basically made as vSAM calls. And so by using these VirtIO devices, now we are writing to these vSAM linear data sets. And again, we can do things like Z hyperlink, IO fabric diagnostics. We have built-in host-based encryption if you use pervasive encryption. We have replication technologies, and we have hyperswap available to Linux applications. This is pretty cool stuff, right? Let's talk a little bit about network integration. So network integration, as we said before, uses this thing called same host to be able to communicate between our zOS address spaces and our ZCX server. And so when an application in Linux or an application in zOS wants to talk with each other, they're going to be using TCP/IP, and they're going to be using, maybe an HTTP protocol, for example, a REST API call to communicate back and forth between these applications. Now, it's very important to understand there is no shortcut for a Linux application to directly talk to a zOS address space or to use common storage or anything like that. It's not there. And it doesn't make sense why you'd want to do that anyway, because these applications don't even know that they're running on zOS. They just work. And so they're using standard Linux interfaces, and they're using this high-speed network. Now we have this dVIPA address, again, associated one for every ZCX server that we stand up. And you'll see that there are cases where you might want to have multiple ZCX servers on a single zOS image, okay? So again, all communications between the containers and the zOS applications are over TCP/IP. But when a request comes in from outside and is destined for ZCX, it's going to specify the dVIPA and the port for your container application within that ZCX. And you're going to be able to support a feature called inbound work queuing, which is going to, again, improve queue depths, and it's going to allow even TCP/IP to be dispatched onto a zip engine. So IWQ, important technology when we're talking about the network integration. And last but not least, the external network access does have zOS IP filters, again, to restrict external access. So that same technology is available that you would normally have. So this is how we integrate with the network. Now, let's talk a little bit about moving Docker containers to ZCX. So when we have today, when we have a zOS here and it's talking to Linux and then it's talking to an external environment, this is kind of what we talked about with the system of engagement and system of record. We have multiple network hops here that are taking place. If my external IP network on the right here wants to talk to my application, which is a Linux-based application, and then wants to talk to zOS, there's two network hops, as opposed to the bottom diagram. We have an external IP network is communicating to ZCX. That is an external hop, but now the second hop is only a cross-memory virtual network. And so we're going to afford the latency on that second network hop is tremendously lower than that you would experience with the double network hop. So in our tests back at the shop, for interactive workloads, the network latency was reduced by up to 45% and increased the network transaction rates by 81%. But for streaming workloads, it was even better, 67, and increasing throughput by over 200%. And I can tell you from a couple clients that we have enabled this technology, and for clients that have moved actually x86 work over to ZCX, they've seen numbers even better than this. So of course, your mileage will vary depending on the nature of the applications and how much data you're transmitting. But suffice it to say that your network latency and your throughput are going to go up. Okay. Any questions at this point? Okay.
Hello, Steve, carry on.
Okay, great. Okay, so let's talk a little bit about the CPU, memory, and workload management of ZCX. So let's talk about memory management. So each ZCX server is provisioned as its own address space, and each one of those servers needs its own memory, and that memory is going to be memory that is fixed memory. So just as a primer for those folks in zOS who are listening here that don't know the concepts of what fixed memory means, basically when you page fix memory, that basically takes that memory off the table from other applications to utilize. Okay, you can't share that with other systems. So in essence, each zOS ZCX server is going to need to have its own dedicated amount of memory that's associated with that server. So if I have two servers, I'm going to have two pools of memory that I'm going to have available for those two servers. Okay, that's the first thing. So memory management, it's managed again by VSM and RSM as any address space would. In terms of, we'll talk about memory backing also in part 2 of this session, which is tomorrow, I believe at the same time. We'll talk a lot more details about considerations for all these things. This is sort of like a high level overview here. In terms of CPU management, each ZCX requires you to specify a virtual number of CPUs. These CPUs translate into tasks under the covers. So zOS MBS tasks or TCBs. So how many concurrent things do I need to have running inside of ZCX? That's going to depend on your application or how many applications I have running and what workload I have running inside of that application. Suffice it to say, that is not a different conversation than we have for any other address space that has multiple TCBs. If you have multiple TCBs and I only have one processor that those multiple TCBs are running on, guess what? You're not really running in parallel. You're running one thread and then that thread stops and then the second thread starts and then, et cetera. So if you really want true multitasking, of course, you're going to have enough engines for it to be able to run. And so zips are what this work gets dispatched on. Almost all the workload in ZCX is going to run on a zip. So we're going to want to make sure for however many virtual CPUs that we specify for the appliance that we're going to have zips that are going to be able to fulfill the multi-threaded requirements of your ZCX. And again, we can have multiple container instances in here. So again, that's going to have an effect on that. Again, normal workload manager policy and resource controls. So service class associations, importance. We can specify resource groups or tenant resource groups, again, to cap the amount of CPU and memory that your entire ZCX appliance can consume. And then, of course, normal SMF data is available. So again, so you can enable by having that data available. Now I can use standard RMF reports. I can do normal performance management and capacity planning with those things in play. Okay. So there may be cases where I am going to want to deploy more than one ZCX server. It could be for availability reasons. It could be that I want to isolate applications. Certain applications may, I want to have that with a dedicated amount of resources available to it. I don't want other applications to take away from that resources. I also have the idea of priorities. This is a big one. So Workload Manager understands the ZCX server, ZCX address spaces. It doesn't understand individual containers running in here. So I can give Workload Manager a priority for a particular started task on my zOS box, and likewise, ZCX is a started task, and so I can give Workload Manager a priority for my ZCX server. But if I have multiple applications, some of which have a higher priority than others, I probably want to consider putting them in different ZCX servers, because I then can control the priority, and Workload Manager is going to be more accurate in terms of giving the right priorities to your workloads running inside of those started server address spaces. So again, each ZCX address space has its own assigned storage, network, and memory resources. So it's going to have its own DVIPA. It's going to have its own disks and it's going to have its own memory, which is page fixed, right? It is going to share the CPU resources, of course, with other address spaces, but of course, your workload manager policy is going to have an effect on how many engines a particular address space gets, just like any other address space on your system. Okay, I'll just keep moving on here just to make sure we have enough time. So let's talk about operations and disaster recovery support. So because it's a regular address space, we support start and stop commands. There is a modify command that allows you to do mostly display-like functions to display the configuration of ZCX that is available for the address space. I can also use automated operations as I would any other address space on the system. So I can use IBM system automation. I can use ARM to automatically restart, or any other zOS automation framework or product to be able to start. So for example, if I want to start something in place, if I bring down my ZCX server, I can have my automation or ARM or other other frameworks to be able to just restart it in place. So that's a very simple example, right? What happens if I have multiple systems in my sysplex, okay? And I want to be able to start my ZCX on any one of those systems. Well, as long as I have shared DASD amongst those systems, and as long as I have the necessary definitions set up in terms of networking, I can do this. So if system A goes down, or if I want to bring down the Docker server on system A, I can then restart it over on system B, and the dVipa will automatically move over. I still have access to the same shared vSAM disks, and so I can just move it over to that other system. And this is very useful for both, for unplanned outages or disaster recovery coordination, right? We can also do this on a site basis as well. So in this case, if I have multi sites that I'm dealing with, and I have some kind of replication solution for my vSAM datasets that are being used as Linux disks by my appliance, I can now actually have a disaster and to be able to recover that with the dVipa moving over just like it does for a lot of your middleware products and other folks that use dVipa, and I can move my entire ZCX server over to the other site. So lots of power, lots of flexibility in terms of moving things. Again, leveraging zOS technologies under the covers. So let's talk about some of the personas here in the last 10 minutes or so here that are involved, and what types of things that they would be concerned about when we're dealing with standing up a ZCX and managing a ZCX. Again, I would highly encourage you to attend the session tomorrow, part 2, where we're going to get into a lot more details about these slides that we're going to be talking about here in just a few moments. But for provisioning perspective, so my zOS system programmer is going to be responsible for doing the capacity planning for being able to stand up a ZCX. How much memory, how many virtual CPUs do I want to specify? How do I get I need to get a dVipa address. I need to get a bunch of vSAM disks, vSAM storage that I can create my Linux disks from. Those are the things that we need to worry about there. The system programmer is likely going to want to talk to whoever is going to be the Docker admin to say, hey, I need to know what logging options you want for containers. Do you have a particular registry that you pull Docker images from that I need to, be worried about? Now, the good news about this is that even if you stand it up, you can make modifications to the to these things, such as logging options and registries, at a later point in time using a upgrade workflow to actually accomplish that. Okay, so these are some of the things that you have to be concerned about. Again, tomorrow we talk a lot more about that in part 2. Again, we use zOSMF workflows. There is no manual way of doing this without using the workflows. But if you have zOSMF stood up, it actually is like a standard workflow. It asks you for a series of questions that you have to do as part of the capacity planning step. You're going to fill in the blanks, and it even provides help and guidance for you to be able to, understand what it's asking for. And so once you've done that, you've gone through the workflow, you can then start that started task up, and now you can do normal operations procedures using for that particular started task. And we have a bunch of workflows. You can provision, you can reconfigure, you can update, you can add disks, you can deprovision the instance. They're all different zOSMF workflows that are provided with the product that you can use to do all these type of functions. Okay, in terms of the Docker interface, so that's where the Docker admin is going to come into play. So what you're going to do is once the ZCX server is provisioned, you're going to want to create a logon for the Docker admin so that the Docker admin can now do his or her thing to be able to stand up various containers that are going to be interacting with zOS, right? So again, using a standard SSH client, the admin can now log on and perform those functions. There's also other functionality that's provided, and I'll show you that in just a moment. But once you're at the Docker command line, all the Docker commands, this is simply what a Docker from the Docker publications, all the commands that you can use for Docker, they work inside of that SSH that's connected to your ZCX server that's running as a started task on zOS. In terms of user management, you have a number of different options here, and we're just going to cover this in literally about 1 minute. So for user management, I would highly recommend when you're first starting out is to use something called the local appliance registry. What that means is those user IDs are going to be created by your Docker admin for what can be authenticated. So it's a much simpler framework. It's simply issuing a couple of shell commands to basically add users and assign them to particular groups that they need access to. And now I can log on, I can provide authentication through those user IDs. And that's a good way to first start up. Once you're a little more comfortable with that, with ZCX, you may want to consider to have using LDAP as your security mechanism. So ZCX provides an LDAP client as part of the appliance, and when to authenticate folks coming into your ZCX, you can set it up so that LDAP will then reach out, and if you have it with, for example, in this example, RACF integration, you can actually authenticate using standard RACF credentials. So this is a more sophisticated setup. It does require a bit more work to set up the LDAP, but once you have that set up, it's very powerful, and you're authenticating through your standard ESM that you have on zOS. And last but not least, you can use a remote LDAP server. If you have enterprise level security, you can actually use your LDAP client to communicate with an LDAP server. Or open LDAP Active Directory, for example. Of course, we support, besides the command line interface, we support Portainer. This is a graphical user interface that allows you to manage your ZCX instance and to see in a way that kind of prompts you for all of the parameters rather than having to know the syntax on the command line. Very useful. Some clients have said, oh, this is a godsend because I'm not familiar with Docker commands, and this really allows me to have some benefits. All right, switching gears again. A lot of folks have also asked, we'll talk more about this in part 3 of the sessions here, but just as a little teaser here, a lot of folks have said, you know what, it's great that we have a lot of these images that we can get out of the box on Docker Hub, but my corporate folks are never going to allow me to actually download applications from Docker Hub and run them on Z, because these are not vetted applications, and who knows if there's unintended binaries inside of these images that are out there on Docker Hub. And so what IBM has done And if you you can actually click on this icon here to actually get started today, is we provided something called the IBM Z and Linux One Container Registry. And this registry has images that were built by IBM, that were scanned for known vulnerabilities by IBM, and the IBM provides a hash for each image. So you can have secure pulls from that image to your ZCX. And the best thing of all, it doesn't cost anything. And they take suggestions for other common packages that maybe are not out there right now. I know there's at least 60 or 70 packages that are out there that you can avail yourself of and have a vetted copy of a particular piece of software and a secure location. So just this is available to you, and I'd encourage you to check this IBM Z and Linux One Container Registry. Talking about just quickly about performance monitoring on the system. So for performance monitoring, we have the ability with Workload Manager to see the performance characteristics at the address space level. So at the ZCX server level, we're able to see how much the whole server is using in terms of CPU, in terms of memory, IO, and the whole anything that can be visualized by any address space. Of course, we can have visualization into that, right? However, we cannot monitor at the container level. So if I have 5 containers running inside a single ZCX, how do I know which one of those containers is eating up all the resources? Well, the answer is using these open source utilities, all of which are available on that thing I just talked about before, the IBM Z and Linux One Container Registry. Using this set of tooling, I'm able to have a visualization of individual containers' performance and what those individual containers are utilizing on the system. And we'll talk more about this in other sessions, but just as a teaser, there is the ability to have a visualization at a very granular level, and using, again, tools that a lot of folks in the distributed world use, tools such as Prometheus, Grafana, cAdvisor, and Node Exporter. Clustering and orchestration. Of course, we're dealing with zOS, so we have to talk about high availability, because that's the one of the big tenets of the Z platform is availability. So with ZCX provides out of the box something called Docker Swarm clustering. And with Docker Swarm, you're able to have multiple ZCX servers that participate together in one swarm to provide higher availability, so that if one server goes down, the other members in the swarm can take over that work, again, for higher availability. Now, we understand that this Docker Swarm does not include a Kubernetes clustering. And so a statement of direction was made close to the time of GA of 2.4 and of ZCX that there would be a Kubernetes solution. Stay tuned for that. There's going to be more information coming out soon about support for that. And so there is a direction that eventually these applications running in ZCX will be able to take advantage of Kubernetes-like clustering. So to get started today, what do you need? Again, you're going to need to be running on at least 2.4. I imagine most of you already are. If you have 2.5, even better, right? So 2.4 or 2.5, it was not rolled back to 2.3. You need to have zOSMF installed, running, and be able to run the workflow engine from your driving system. So the system that's going to actually be provisioning and deprovisioning, you need to have zOSMF workflows to be able to run on that. I would imagine most folks have that, because a lot of folks are now using the upgrade workflow, for example, for zOSMF. The next item is obtaining rights to use ZCX. So again, you need a hardware one-time purchase of a hardware feature code 0104, or the IBM Container Hosting Foundation for zOS component installed. Again, either one of those solutions provides you to have your entire CPC or KEK to have as many ZCX instances on that KEK as you wish. Or you can use the ZCX trial. you can use that using the IFA PRD ParmLive member that you can enable dynamically to be able to start your try and buy for that. Again, so besides having zOS MF and having the right hardware and zOS levels, you're going to need, of course, to plan all your resources. So this is, we're talking about memory, storage, zip engines, dvipa, that type of stuff. Then you're going to provision your ZCX. You're going to start it from, you know, a regular zOS command line, and then you're going to be able to tell your Docker admin to log on and install your Docker applications. Okay, so we're right at the top of the hour. I'm just going to tell you about the 2 sessions. So tomorrow at 2 p.m. or 1400 hours, we'll have part 2. This will actually show you what you need to get started to stand up a ZCX instance. I also even will have a live demo of provisioning a ZCX instance. So you probably want to come by and see that, some cool stuff. And then on next Tuesday at 15:30, at 3:30 in the afternoon, we will have a session about practical use cases of using ZCX. And so we're going to talk about some of the different ways that folks are using ZCX to be able to provide that lower latency, higher availability, better qualities of service, not having to provision a Linux server, etc. There are more resources available here, and you can look at this on your handout. And there are even some YouTube videos that are out there. There's also a workshop that we offer. It's a free workshop to help folks get started. So if you want to avail yourself of that, you can drop me a line and I'll be happy to see if we can, you know, be able to hook up with your client, with your company to deploy ZCX, and the workshop will address about 12 hours worth of education and customized for you. And again, no charge. That's all I have. I want to thank you for your time. Are there any questions in the chat before we go? Either I explained things so incredibly clear that you guys don't have any possible question, or maybe I put you to sleep. I don't know what.
Definitely the former, Steve, I think. Yeah, another great presentation. Thank you. Definitely looking forward to part 2 tomorrow and part 3 on Tuesday. Yeah, I think, yeah, don't forget, submit your feedback for Steve's sessions. That'd be much appreciated. If you do have any questions, I think, Steve, your contact details are available, or get in touch with myself or Rui, and we'll be happy to pass them on. Yeah, as we got no questions, that concludes the Large Systems stream for today. We're back on air tomorrow at 9 o'clock talking GDPS with Dave Clitheroe. So with that, thank you. Have a wonderful evening. Thanks again, Steve. Very much appreciated. We'll see you again tomorrow. Thanks all.
All right. Thanks, guys.
Cheerio.